Alright, this video is in response to Brandon wanting me to kind of show how I use heat and cold to isolate electronic components. This is everybody's most beloved board, GE's refrigerator control board. Sorry, I had to say it. I know everybody knows it already. So anyways, what we're doing here is I got 120 volts coming in, and then, sorry, there. This guy right here is the 12 volt output, which everybody also knows if you put your meter leads on there, you're going to probably get about 13.5 volts normally. So right now I got my scope set up, as well as two lights and LED lights, as well as a fan back here. There we go, that fan's running on it, and we're running at my anemometer is showing 2.89 meters per second. And this right here, you see these two pop caps. I think all of you know those pop caps of death. And so let's get down to it then. First of all, let's relieve the load a bit. Okay, so what I'm going to do is take this light out of the circuit. Now you can see immediately we're already up higher on my fan speed. Okay. Also, if we look at the scope, it's basically the more you load it down, the more the voltage goes down. Now, what I'm going to do is actually take a look with this circuit when we heat the power supply, and so I'm going to do that with my heat gun over here. Let's get that back in place. There we go. Look, I bought this thing at Lowe's. I'm just gonna check our scope and see what voltage we can get it up to with no load. So we got that voltage rising, as you can see, and that's with the fan off. And now I'm going to disconnect the final light. You can see it just rise up there. So let's get everything back going here. I'm also going to check that the AC component, and there's a couple of components there riding, and so I'm going to just do a rough measure of that guy. There we go, finally got it. So there's the DC with the AC coupling. That's AC only, and as you can see, the ground is just my baseline down here. I just set it up because it's a kind of a wide range we're looking at right now. Alright, so what happens when we heat up the circuit that we know is bad, that power supply, bad caps? Let's take a look at that scope and see what happens. You can already see the AC is getting smaller, and as I heat it up, the voltage is climbing. Now what's happening there is that the heat is stimulating the dried up capacitors. The electrolytic material inside is just exciting it. The electrons are just kind of spinning faster in there, and so it's able to transfer more current. So let's see where we're at right now on it. Okay, that's a considerable difference. We're gonna go. Let's see. So it's 2 volts per division. 1, 2, 3, 4, 5, 6. That's 12. Let's call it 12.3 volts. 12.2, 12.3 volts. We were at 1, 2, 3, 4, 5. We're about. Well, you can see the AC component makes it hard to read, but probably in the upper 9 volts. So just by heating it, we took it to upper 9 volts to over 12 volts. That's all I was doing, was heating those that part of the power supply, the capacitors. So you can see how the heat will influence it. Now, in the same manner, what I'm going to do is freeze those caps again. Now, what I was saying on Voxer, and you can see the voltage going down again. Yeah, obviously it's gonna take a little time, but that's why you also want to use this. You can see the AC component starting to get larger as well. That's why you want to use the heat and the freeze spray kind of sparingly. One, the freeze spray can actually make the air condense, the moisture in the air, the humidity in the air condense, and it can actually cause it to short components, especially like ICs. So you want to be careful around those. The heat gun, if you heat IC directly like this, that will make it go defective. So in general, when I heat, I kind of, as well as freeze, I kind of massage it like this, kind of all the way around, bring it back. Remember, you know, these heat guns, 1,000, 1,100 degrees Fahrenheit, at its highest point. So you can damage a board pretty easily. So just be careful when you're doing it. Don't sit on any one component for any. Now, a resistor, it's not as susceptible to heat, but some of these other components that are more discrete, like the little chips here, here. Sorry if it's not so clear on the camera, these guys. Then you just want to be careful around the discrete components and the ICs. So that's it. If you have any questions, let me know.